each bottle is going to be registered here. So when the sequence is completed, I want loading this item to be done by automated method, not me coming here to press this again. So because of that, I'm going to have a latch here. I'm going to have a latch here, and that latch is going to be our sequence repeater. Okay, beautiful. This is our sequence repeater. Then this one is going to be our um, product counter. Let's say product counter. Product counter sensor. Let's say product counter sensor. Let's see. I have a product counter sensor. Let's find that sensor here. Production. I have another name for that sensor. Okay, counting sensor. Better. That this name is better. Item counter sensor. Each item that passes, these sensors count it and send it to this counter. Okay, so this sensor will sense the item and load it to this counter. This counter now recognizes by registering it here. So this can be another bit you can use to reflect what this one is being registered. Okay, it can be done that way. All right, so we are done with this, but let me come again. This counter is responsible for registering number of bottles counted by this. Okay, and the counting of this sensor is going to do the counting. Then this one now acknowledge the counting, register the number of items counted by the sensor. Okay, all right. I repeat again, number of items passing along the conveyor. This sensor is responsible to count number of items passing by. So when it counts, the registering is going to come here. The counter is going to take that value and send to PLC, telling PLC that this is the number counted by this sensor. Okay, so this particular device is like a storage memory that this counter sends the signal to. Then this one transfer that information to PLC. Okay, all right, to display, because they're going to be a display unit where you can see the actual registering output of the figure. Then this one, I'm going to use this one to activate this output. This output is not the value counted. It's not reflecting the value counted. It's reflecting the activity of this. It's reflecting that this is on or this is off. When this one is off, here will go off. When this one is on, here will come on. So here is reflecting, telling the activity that is going on here. This one is telling you that this counter is on or this counter is off. So it's giving all the status of the counter. So I can use the status of this to activate another bit or deactivate another bit. So that's the essence of this. Okay. All right. Um, let me show you this. Let's do, okay, we are done with this network. Okay, so the next network now is the timer. Like I told you, I said once this one is deactivated, timer is going to come up. Okay, so the next network is going to be our timer. So let's do that now. This is my timer. So I will now invite the services of that my logic. Now, the reason why I want to use logic to activate this network of timer, I don't want to use um, I don't want to use conveyor is because conveyor is going to be shut down for timer to get activated. So if I use conveyor, just like I use conveyor here, if I use conveyor where conveyor is shut down, this timer logic will be shut. The network will be shut down. So because of that, I'm going to use my lashing I'm going to use my memory bit, that is latch logic, this one, latch the logic. I'm going to use it because it's my initiator of the whole sequence. I'm going to use it to introduce my signal here. After that, I now put a counter bit. Then before now, I get my timer. So this is my timer. I should use this one. Should use this on delay timer. Okay, then I need output for the timer. All right, so for me to energize this network, I should have a permission from my latch logic. Latch logic should give me permission to come here. Then this one is going to be my counter. Okay, this is T, maybe T1, because that's the first timer in the network. Then what do we have here? Maybe I put this one to be sequence initiator, sequence repeater. Okay, it's going to be sequence repeater. Why I call it sequence repeater? That means when this one is the output of this is coming here, is going to now repeat that sequence again. Look at it. So this output is the one repeating that process of counting again to continue again. After each counting, another process of counting process should commence and is going to be initiated by this output timer. The output we are getting from timer should initiate that command by resetting this value, sending this value into this counter. You remember I told you that for this value to be recognized right inside the timer, we need to load the value by clicking this bit to load this value into this timer, into this counter. That is what you need to do manually before you start the operation. But subsequent time, you don't need to come and press it again. The timer, that timer, this timer bit will be doing it for you. So this bit here, this output will be coming here to initiate that loading this into this counter. Okay, so that is that. Then how many seconds do we need? Let's say for testing sake, let's say 8 seconds. Timer should hold on for 8 seconds to enable another process machine to evacuate the dozen produced or a set of item produced before another set will commence production. Okay, all right. So if that is done, we are done with the network. Network one, network two, network three. That is the three network that we have. From this narrative, from this narrative, look at it, network one, two, and three. That is end of our instruction. But I want another counter. Like I said before, let's insert another counter. The work of this counter is to register the dozen produced per each sequence. Okay, each pallet completed, this one will register it and continue another pallet. That is the function. But I want another counter that will count the entire pallet, the entire number that make how many pallet produced. So because of that, we are going to introduce another counter. Okay, so this counter would be product counting sensor. Do we have product counting sensor here? Okay, quantity produced. So we have we're going to have this bit and now have count up. This one is a counter that will count down. Counting down meaning that we want we want eight, these eight numbers. We need a eight number of bottles or eight number of items to be completed in one particular sequence. So because of that, this one will count 10. So because it's counting 10, so you're going to be counting 10, 9, 8, 7. So you're going to count down. When you count to 0, it will now deactivate conveyor. So that is why we are using count down. Then, but in this case, we want to count the total number of items produced in operation or per day. We are going to count up to capture every production. So it's going to be a cumulative production per operation or per day So in that case, we are using counting up counter. So come here, you pick count up, now come back to count instruction, then we repeat this one. This is count up. So we are using the address to be C2 because that is the second counter in our logic. Now, how do I still need the output. Output can be, um, we can now call output to be, let's check the name here, maybe total, okay, we say total product counter sensor. Going to be total production, total product counting sensor. We're going to be registering, or it can be anything, it can be anything. We can also decide not to put anything there. We can decide not to put anything there. We can decide to do away with output. We're not using it. But we want it to register. So we're not using it. You can use it. You cannot, if you don't want, you can leave it. So, okay, now how do we count? What sensor will do this? We need another sensor. Okay, so we're going to take advantage of this sensor here. This is our item counting sensor. So we're going to take this address here. I'm going to copy this address and use it because it's the one counting. We're going to use it here. So it's going to give us, so once it's counting, simultaneously this one will also be counting. Okay, so if this one count 10 and stop, in that case you have produced each pallet. If this one count 20, there is 2 pallet, this one will also register 20. Okay, if this one count 10 2 times, this one will register 20. If this one count 30, that is 3 times, this one will register 30. So I want to capture every product produced. All right. Okay, now if I now needed to introduce another network, okay, by a way of saying, let's say if we can put indicator lamps that will indicate whenever each of those operation is active. So what I will do is quite simple. We put output here. This one will come up when the lashing logic is on. This one will come up to tell us that the system is on for operation. There is a operation indicator lamp, for instance. Then if I also needed another lamp to illustrate and telling us that there is a conveyor on, I can put it this way. Then another one again can come this other way. I need maybe another lamp to illuminate, telling me that the counter is working or counter is not working. Whenever the counter is counting, I want lamp to be flashing, telling me the counting signal. So I will do that. Okay. Then if I also need perhaps I need what other operation you need. Okay, this one is okay. So I will now take Lash logic should lead my network, should be the bit to initiate the command to the network first. So once this one is true, I should have this one on. So this one can be, let's give the, where do we have output here? We have a output 0. I 0. This is conveyor 1. Then this one is 2, the output of this. And we use that quantity. Did we use that for anything here? Okay, it's just there doing nothing. If I had known, I wouldn't have used this. I will use it for, okay, it's memory bit, it's not output. It's only one output that I have. Okay, so in that case, I will use this one to be I 0. Sorry, Q 0. Q 0.1 because I have 0 before. Then this one is going to be Q 0.2. Okay, I have this before. I have this total whatever. So I will change it to Q 0.3. Then this one should be Q 0.4. Then this one should be Q 0.5. Okay, so these are indicator output. All right, so this one should come up immediately the lashing network is activated. This one will come up, okay, telling me that the system is being energized. Then when conveyor come up, this one should come up. So in that case, I should have main conveyor auxiliary here to give me permission to illuminate this. Then if the counter is on, if the counter is on, so in that case, I have output for the counter here. Look at it, look at the output, M0.1. So I should have the bit. This one should give me the instruction telling me that the counter output is working. Okay. Or yes. So in that case, I should have quantity, total quantity, whatever. I think that production. Slide the sensor there. Check the name again. Quality control is quality control, not that one. So what I'll do, just delete that. Just come here, take the quality control, copy this, copy it, and go there and paste. The address will come out automatically. Paste it here. Okay, that's the address. So once that one closes, I will have this one on. Okay, so this logic now belongs to our signal lamp. Another advantage of you having this is because in a complex design, okay, in a complex logic, you may not have the opportunity to have the whole of the logic and go through them. So everything will be segmented in block form. Okay, there's what we call, let me show you the block here. Come here, you see block. So you come here, it now create a function block. So each of your logic should have function block, each of some extended logic we have, like this logic we just designed now is embedded in one block. The name of the block is look at the name, conveyor and counter logic, is on FC1. So if I create another FC2, I should, in a complex design, you segment them by creating FC function block, function block, function block. Okay, okay. Um, Function, sorry, creating function, yes, function block. So if you create them that way, if you have an issue, you can easily come to one particular block and open it, maybe a signaling lamp block, open it while simulating that same logic. You come to this place only. If this one is not on, you can easily dictate that logic, um set logic network is not working. So you can easily go to set logic network and find out why it's not working, because it's not reflecting indicator here. So you don't need to go through the whole of the logic checking the fault. Then if you have an issue with conveyor, conveyor is not coming up, you can easily go to a block, a FC block that's responsible for conveyor. There is, I'm talking about where you have a complex logic, like each of the network will contain, each logic here will contain like 4 network in one. Then another sequence will continue from another network, contain another 3 network again. So in that case, segment them by block so that troubleshooting will make easy. All right. So if that is carried, let's now simulate. Okay. All right. How do we simulate? We save our program and compile it and load it to the PLC. Okay, if that is done, then you are going to put on your simulation and the monitor. Okay, the program is set for testing. So let's simulate now. Now, before we simulate, come back to your counter. In our counter here, we have value here as 10. This 10, like I said, this 10 is going to be, bring our narrative. This 10 is going to be the dozen, for instance. It can be any value, but we are using 10 because of simulation, because of time, so that it will be very, it will not waste time counting number. So we can count 10 very easy. We can as well change it to 5. Okay, so we are taking 10 to make our dozen. We are taking 10 to make our dozen. Let's reduce it. Let's make it 5. Let's make it 5. Okay, so we are using 5 to make our set, one particular dozen. Okay, so now um, let us monitor and simulate now. Now, this counter here, we have value of 5. We are yet to download that 5 into the counter. So how do we go that? Look at value loader. I will click this bit to load this one into this counter, so that this counter will now understand that we have this value in it. Look at here, it's showing C hash 0. This value is not recognized yet by the counter until you load it here. Then figure here, this 5 here will come back here to reflect there. So let's load it now by activating this bit M3. Come to this and load it now. It's now loaded. It's now showing 5 there. So we are ready now to start the operation. Okay, what I have just done is what maybe operations manager or supervisor will do for before the operation commences. How many you want to produce, you put on these data and get them ready before you initiate the operation. So if you want to produce maybe today some of your cartons, some of your production wrapping packet, some are 5, make a 12, make one set, some are 24, make one set, some are different number, make one set. So whichever package you want to produce in a day, you now go to your PLC and they input that value. That is what I